So wow, this is Mr. Coolis. This is crazy. I don't even know what to feel about teaching this to you this way. I'm going to try to connect with you as well as I can. Be assured that the teachers here, we care about you, we love you, and we want to see you do well. So we're going to take care of you as best we can. I'm going to teach my lessons this way. This is video lesson number 1. It is chapter 10.1. We've actually done a little bit about this last week, but we're going to start over. We're going to go as slow as we can and make sure that you guys have the knowledge that you need and hopefully the connection that you need with us in order to be successful. So chapter 10.1 was on area and perimeter of figures. I have the figures up here that we're going to be talking about. We have rectangles, squares, triangles, trapezoids, parallelograms, and quadrilaterals. And please note to try to keep these videos as short as I can. I'm going to go kind of fast, so it'll be your job to pause them where you need to get the information down. This lesson here is on my Canvas site, so you can go to that Canvas site and get what you need off of there. This note sheet, some of you maybe already have it. So area formulas, rectangle. Area is base times height. Make sure that your base and height are perpendicular. There's your H and there's your B. Area of a square is also base times height. Again, we have a base and a height there. Usually for a square, what it is, sometimes they call it, instead of base and height, sometimes they call it side and side, and they'll write an area formula that's side squared. Either one of those two formulas will work. For a triangle, area is equal to 1/2 the base times the height. Again, the height has to come in at a right angle. So many times on a triangle, you're going to have to dot in the little height there. Call that the B and call that the H, and it's 1/2 BH. For a trapezoid is 1/2 of base 1 and base 2 times the height. This is base 1, this is base 2, and again, the height comes straight down. Parallelogram, base times height. Base, height can be outside, or the height can be inside. But it's got to come from there straight down at a right angle. And then one you've probably never seen before. If the quadrilateral, the four-sided figure, has perpendicular diagonals, we would call this distance right here diagonal 1, and we would call this distance right here diagonal 2. And when it has perpendicular diagonals, what you do is you take half the total length of that diagonal times the total length of that diagonal. And the one this would work for would be like a kite. Some rhombuses are this way, squares. This formula actually works for a square also. The one thing I didn't do is I didn't do perimeter formulas because I only have one perimeter formula for everything. And you can write this at the top of this page. The perimeter is add all sides. I don't care. I mean, if you look up in a textbook, it might say this perimeter for this is 2 length times 2 width. The perimeter for this one is 4S. The perimeter for this one is A, B, and C. But what I'll do with this is I'll just say, hey, perimeter for any type of straight-sided figure. If it has straight sides, it's simply add all sides. Along with this, there's a little section I call the bendy ones. What if the figure doesn't have a right angle? Where are all those possible spots that you could have the height? So this is a parallelogram, and its area is equal to base times the height. And where could the height be? Well, it could be there. It could actually be in here if they're both right angles with the two top and the bottom with the bases, or it could appear outside. There could be the height. So we have area is equal to base times height for that one. For this trapezoid, that could be the height. That could be the height. Heck, the height could even appear outside. That could be the height. And this one, area is equal to 1/2 base 1 plus base 2 times the height. And whatever that H value is, you'd plug in there. Base 1 and base 2 are right there. And then the triangle, sometimes it's a right triangle. and you might have the height here and the base here. But a lot of times it's a triangle that kind of sits like this, where you'd call that the base. And again, we have to dot in our height, and I have an h there, and our area formula there is 1/2 base times height. And for this lesson, those formulas are really going to govern what we do. And I'll show you how to use those formulas in the next section. Okay, here's part 2, example problems. First example problem says find the perimeter and area. And I'm going to use those formulas from before. Hopefully you have them written down from what we did in the last video, in the last section. I'm going to use those formulas. I'm going to find perimeter and area, whatever it is. So this is a parallelogram, and whenever they put little dotty in parts like that, that chunk is not actually part of the parallelogram. That chunk is just there to help you with measurements. So perimeter is going to be at all sides. That one's pretty easy. 6, 7, there's a 6 and there's a 7. So 6 plus 7 plus 6 plus 7, that's 13 and 13. And I got 26 for that. And by the way, on these videos, do not be surprised if I make mistakes. There's a great chance of that. So if you find an error in something that I do, just understand that I'm human also. So that's 26, and we'll probably label it as 26 units. And then I need the area. And sometimes on these area problems is where it gets a little sticky, because I have this, but I need the height, and the height on this one is going to be outside, but I'm not actually given the height. So when you do these problems, you're going to have to think SOHCAHTOA, you're going to have to think 30, 60, 90, 45, 45, 90, and specifically this one, this is a Pythagorean Theorem problem, so I'm going to do that. So I'm going to go 3 squared plus the height. I'm just going to put in h squared equals 7 squared. That's 9 plus h squared is 49. 49, I'll subtract the 9 off. I got my h squared value is equal to 40, and then I'll square root it. And I am going to write it in this section. I'm going to write it like I would on the ACT, because I know there's a decimal associated with 40, but the ACT is going to give you the simplified radical version. So 40, 4 times 10, and I'll take the 4 and I'll pull it out, and I got 2 root 10. So area formula for parallelogram. Area is equal to base times height. My base is only this part, the 6, and my height is the 2 root 10, and I got 12 radical 10. And I do think there's some value right now in taking a calculator and find both the radical form and the decimal form. So I'm going to type in 12 root 10, and you should have a calculator out, and you should be doing this with me. And if you don't have that, pause the video right now and go find one. But I got 12 root 10 for the answer, which is 37.9. So exactly 12 root 10, approximately 37.9. And we can call that units squared. The first one, this value is the exact value, this value is the decimal approximation. All right, next one. The area of a rectangle is 96, the base is 4. What is the height? No picture drawn. I'm going to start with the picture. The area is 96, the base is 4, and they want to know the height. So given the picture, we can write down a formula. BH, and I'm going to start plugging things in. So 96 goes in for A, 4 goes in for base. 96 equals 4H. And a lot of these will turn into algebra problems where I have to isolate a variable. So they want to find the H, so I isolate the H, divide by 4, and my H value is 96 divided by 4. Again, the expectation here is that you're hitting buttons with me. Don't just let me do it on my calculator. You should be plugging those values in also. So 24 units, height of the rectangle. All right, next one. The area of a parallelogram is this expression, find the height of the parallelogram if the base is 2x. And on a section like this, on a problem like this, you're going to have x's in your answer. You won't always get like height is 12 or area is 13. you might get height is 2x plus 3 or some weird thing like that. So this one, area of a parallelogram, I know the formula, base times height, and my area is this. I'm going to plug that in for the area. 4x cubed minus 2x squared plus x. In for the b goes 2x. And then the h is this value that we're trying to find. And you might notice there's a bunch of different variables in this thing, which tells me my answer is likely to have multiple variables. But anyway, I want to get the h by itself. So I'll divide by the 2x. And my h value is whatever 2x go into all of those. So let's do the math now. 2 into 4 is 2. X into x cubed leaves me x squared left over. 2, oh, there's a negative sign there. I'm going to bring that along. 2 into 2 is 1. I could put the 1 there or not. X squared over x will be x. And then 2x into 1x, there's a 1 there. So the x's will wipe out and I'll be left with a half. And that's kind of a funky answer, but that's the way it looks when you have expressions in the problem. It's going to look like that. All right, the area of the figure is 12x squared plus x. Find the perimeter of the figure. Area is given, perimeter. I have one piece. I know this up here is going to be 2x also. The problem is I don't have this side. I have to go and find this side before I can find the perimeter. So I'm going to put the area formula. It gives me area again. Area is 12x squared plus x. And it's a rectangle, so that's base times height. So I can set 12x squared plus x equal to the base, which I know the 2x. And then the height again, I don't know. I'm going to put an h there. So I'll divide by 2x. Again, I'm trying to isolate the h, very similar to what I was doing up there. H is equal to, well, that's 6. And x into x squared is x. And I have the same thing I had going on up there. 2x and 1x, it's going to be 1/2. So that's actually an expression for the height. 6x plus 1/2. That would make this 6x plus 1/2. And the perimeter, the end of the problem, would be what I would get if I would add all these up. 6x and 2x and 6x and 2x. Well, that's 8, 9, 10, 16x. And then I have the halves, so it's 16x plus 1 is the perimeter. And this is very representative of what I would see on an ACT type problem. They like to take the algebra and the geometry and really merge them together. So when you hit the ACT, it's not just going to say, hey, the base is 2 and the height is 3, and what's the area? It's going to say the base is given, and here's the area, and find the perimeter. And this is very, very representative of an ACT problem. Okay, the next one, find the area of the trapezoid. Pause the video if you can. Write down the area of a trapezoid formula. Okay, area of a trapezoid formula is 1/2 of b1 plus b2 times the height. That's a b2. And I got a lot of numbers here I can plug in. 1/2. Base 1 is 10, base 2 is 6, or vice versa. It doesn't really matter which order you put it in, but 6 and 10. But the hard part on this problem is I don't actually know the height. So I'm going to dot it in. Something very common that you have to do is create your own height. I'm going to dot that one in. And I'm going to do a little basic geometry. 6, I created a rectangle, so 6. Whole thing is 10, that's 6. So that's got to be 2 and 2. So it goes 2, 6, and 2, make 10 total. So I'll put a 2 there and a 2 there. And the only reason I have that 2 there is because I want to go in and I want to find the height. And you might see this little triangle right here. That's a SOHCAHTOA problem. I have a 75 in that spot. I have a height. I have a 2. So I'm going to say opposite, adjacent. That's a tangent problem. Tangent is opposite, tangent of 75. Opposite h, adjacent 2. And I can cross multiply and solve that out. I can see right now my h value is going to be whatever the tangent of 75 times 2 is. So I'm going to do that. Tangent of 75 times 2. And I got 7.46. 7.46. So in many of these geometry problems, if you're not given a piece that you need, maybe you create a triangle, maybe you do SOHCAHTOA or something like that to figure out what it is. So this is 7.46. That's my height. So I take 1/2 of 16 times 7.46. I can put the half and the 16 together and get 8 times 7.46. And I've just left the 7.46 up on my calculator. I haven't done anything. So I'm going to multiply that right now by 8. And I'm going to get the answer. The area of this figure is approximately 59.7. All right, next one, find an expression. Well, if I see find an expression, I know I'm probably going to have x in my answer again. So it says find an expression for the base of a triangle with an area given and a height of 4x. Well, I'll draw a picture. Find an expression for the base of a triangle. Base of a triangle, the height is 4x, and the area is given. Area is 4x to the 5th minus 2x. Well, I know my area formula is 1/2 the base times the height, so my height is 4x, and now I can solve this thing backwards, similar to what I did before, and I can find the base, find an expression. I'm trying to get this little b value right here. I'm trying to figure out what that b value is. I'm trying to get it by itself. Well, I can put the half and the 4x together and get 2x. And that's my b. And to get the b value here by itself, I divide by the 2x value. And again, it becomes, can you simplify that algebraically? 4 and the 2, reduce down to 2. x5 and x1. Well, 5x's and 1x simplifies down to x to the 4th. 2x and 2x. A lot of people make a mistake here and just get rid of that. I mean, if you reduce those two down, you're left with a 1. You have to have that placeholder. And I got an expression for the base, given the area. All right, next one. Find the perimeter of the trapezoid, given an area of 108. Well, I got base 1, I got a height. Should be a perpendicular height in there. I don't have this base right here. So I'm going to go in and I'm going to find that base. Area is equal to, because it asked me for perimeter, so I definitely need that base. Area is equal to 1/2 of base 1 plus base 2 times the height, which is, area is 108. And then I'm going to take half of 9, and I'll just leave this part base 2, times the height, which I already know is 8. So I get 108 equals half of 8. I'd probably put those two together and put a 4 there. And then 9 plus b squared. And there's a couple things I could do here. I could either distribute, I could actually, probably the easiest way, I'm going to divide the 4 off. And those two cancel out, and I'm left with 9 plus b squared is equal to, well, again, I'll take my calculator. If you don't know 108 divided by 4, you just plug it in. And I got 27. 27 there. And if I move the 9 over, I got my b2 value is equal to 27 minus 9. I got 18. So I'm going to put 18 down here. Okay, so I know that distance. I still don't know those two. But wait a second. I'm going to dot that in. Those two heights would be the same. That's 8. And that makes this thing a 45, 45, 90 right triangle right there. 45, 45, 90. So if that's 8, then this little chunk here is 8. And it goes x, x, x radical 2, which makes that 8 radical 2. So I have that part. All right, a little bit more. I got 8 there. I got 18 total. I got 9 there, so I'll put a 9. Oh, 8 and 9 is 17. I got 18 total on the base. That means there's a 1 here. And I can do the Pythagorean Theorem to find this part right here. There's another right angle. I got 8 squared plus 1 squared equals that hypotenuse squared. That's 64 plus 1 is 65 plus h squared, or equals h squared, and I'll square root. And I got an h value that's root 65, which It's like 8 something. Again, I'm going to try to write the simplified radical version. So I'm going to go, the perimeter is what they want. Well, I got 18 total. I got 9 total. And then I got 8 radical 2. And then I got root 65. Okay? All right, we're going to get in power position now. We're going to get in a stance as we write this down because we want to make sure Coach Marty, you know, we got to bring home power position. So stick your chest out, shoulders back. Okay, that's 27 plus, these two actually won't go together, so I'm going to leave it 8 radical 2 plus root 65. And I have an expression for the perimeter. Yes, there is probably a decimal associated with that. You could run that through your calculator and find the decimal. This is actually what the ACT would look like. That's kind of a hard problem. It's time for the move of the day. Okay, the last section here. Just a few more example problems that go with this, and then we'll be done. This will be great. All right, find the second diagonal of a kite. It's an area of 216 and one diagonal of 12. So again, we got to draw pictures here. So I'll draw my kite. Here is diagonal number 1, diagonal number 2, and I don't really know which one is 12, and it doesn't really matter. The math will work out the same. I'm just going to call this one 12. And this formula is really a weird one. So it's one you probably don't have any background in. So what I'd like you to do is pause the video right now, see if you can go find that from the notes, and write that formula down. Okay, so formula. I hope you went and found it. And the diagonals of a kite are perpendicular. So we use this formula, perpendicular diagonals. It's d1 times d2. And a lot of people will put plus in there. That's a common mistake because they see the area of a trapezoid formula and there's a b1 plus b2, and it's not that. It's d1 times d2. And now I'm going to plug numbers in. So area is 216, 1/2, and one of the diagonals is 12. And the other diagonal, d2, I don't know. And, well, half of 12 is 6. And that's 216. I put those two numbers together, d2. And again, if you don't know 216 divided by 12, you go over to your trusty calculator. I think it's 36. Or divided by 6, I'm sorry. And it's 36. And I have an expression for diagonal 2. Actually, I have a number. It's 36 units. All right, next one. This one says, find the area of a rhombus with d1 and d2 given. So I'll draw a rhombus. The prevailing characteristic of a rhombus, go back and find that formula. Again, the diagonals are perpendicular. And I'll use the same formula for the diagonals of a rhombus. There's my perpendicular, and I bracket them off. D1 doesn't really matter. I'll put 3x plus 4. Here's diagonal 2 is 5x minus 6. And I have this formula. Area equals 1/2 of d1 d2. And I'm going to take 1/2 of the first diagonal, which is 3x plus 4. And the second diagonal is 5x minus 6. And that's an expression, and that's actually a correct expression, but it's not a simplified expression. So really what they want me to do here is I see two parentheses, I see two binomials. This is a FOIL problem. You're going to have to take this thing out and probably FOIL it, and then most likely distribute the half is what I'm going to do with it. So I'm going to take the half, and I'll write my acronym FOIL. So first is 15x squared. Outsides is 18x. Insides, these two is 20x. And the last is minus 24. And usually when you do first, outside, inside, last, you're going to get 4 terms. And those middle terms, a lot of times, they go together. So you know, like live long and prosper, like, but they go together like that. So, and then they combine into one term. So I'm going to take 1/2, and I got 15x squared. That looks like 2x and minus 24. And half of 15, I don't know, I'll probably just leave it 15 over 2. You could write it to 7.5 if you wanted. 15 over 2, x squared. Half of 2 is plus 1x, and then half of 24 is minus 12. So we got that. And 3C, the last one, find the area of this rhombus. And I know the perimeter, it's a rhombus. Can you think about and say the perimeter right now to yourself? Yep, 8, 8, and 8. Perimeter of this rhombus is 8 plus 8 plus 8 plus 8, or 32 square, or just 32 units to be the perimeter. But for the area for the rhombus, really what I'm doing is I'm going to do that diagonal formula. So I'm going to say that the area is 1/2 of d1 times d2. So I'm going to take half of the length of the diagonals, but the problem here is I don't know the diagonal length. So I'm going to have to do some type of SOHCAHTOA, 30, 60, 90, 45, 45, 90 Pythagorean Theorem. So let's look at one of these individual triangles. So I have a 36 there, I have an 8. I need opposite and adjacent. This is just a straight up SOHCAHTOA problem. I'm going to call this part A and call this part B. And if I find B, I'll just double it. If I find A, I'll just double it, and I can plug those values in right there. So let's go opposite hypotenuse. That's sine. Sine of 36 is equal to opposite A over hypotenuse 8. I'll put that over 1. And I got A is equal to the sine of 36. Sine of 36 times 8. And I can find my A value. I need a calculator for this one also. So I'll plug in the sine of 36 times 8. You should be plugging this in also with me as we go through it. I got 4.7-ish. 4.7022. All right, so then the B value will be cosine. So I take the cosine of 36. Cosine of 36 equals adjacent over hypotenuse. Adjacent B, hypotenuse 8. I'll put that over 1. And my B value is whatever the cosine of 36 times 8 is. And I got 6.47. 6.47 for my B value. So if I know this is 4.7, this would be 4.7. These two chunks in a rhombus are the same. And I know if this is 6.47, I know this is 6.47. And I can start figuring out how long diagonal 1 is. Diagonal 1 would be 4.7. I still have that number up on my calculator. So I'm going to crank that in there and then put times 2. I got 9.40 for diagonal 1. And again, diagonal 1 is this whole distance. And then that's 6.47. I'm going to take that and I'm going to multiply that by 2. And I got 12.94. I'll plug in 12.94 there. And I'll run all that through my calculators. 1/2, I'm just going to do 0.5 on my calculator, times the 9.04 number, which I still have up, so I'm just clicking in there. And then I'm going to multiply that times the 12.94, and it's strung together on my calculator, and all I have to do is hit enter. And your number, I hope, is close if you use decimal approximations, but 60.87 is what I got for the area of the rhombus. That's the end of the video lessons for 10.1. The next lesson will have you do some homework. There should be a Canvas quiz. What the Canvas quiz is going to do is it's just going to ask you for some numbers out of this set of problems that I did. So hopefully you watched the video, hopefully you got something out of it, and we'll see you tomorrow.